So my name is Catherine, and this is Claire, and we will be walking through our project, ClueGPT. So the goal of ClueGPT is to supply people with a second clue when they're solving crosswords, when they get stuck. And the motivation behind this is that when people are solving crosswords and when they face any difficulties, they're often left with a few options, which are searching for answers online or just simply giving up. So ClueGPT is an alternative to this tool, and it can be used to help them without being directly given an answer. So the dataset we have used is a New York Times crossword dataset, and the dataset is formatted in the clues in one file and the answers in one file, and the rows corresponding to each row. When we were going through a data set, we encountered several errors in the data, and the examples are given in the answer column, which are like a lot of gibberish. So we removed them so that it doesn't mislead our model when doing our experiments. And in terms of the data processing step, we process the data to this data frame format so we can further use it to develop our prompt. And for the answer column, we first removed the special characters and also removed the spaces and made all letters lowercase for easier comparison. And the other columns, for the number of char and included letters, the number of char is the length of the answer, and the included letters are selected randomly at the time of data processing. The software we use is Python and Google Colab to code our experiments, and then the main model we use is GPT-4. And we use Google Sheets to score and analyze our answers manually. So here's the ClueGPT model architecture. We first prompt GPT-4 with the existing clue and the length of answer, and also the letter positions. And then we ask it to generate a guess. Once we get its guess, we analyze if it matches the answer length and the letter positions. If it is correct, then we ask it to generate a new clue. And if it is not correct, so it doesn't match the letter positions or the answer length, we ask it to try again, but this time excluding its previous incorrect answer. And we ask it to keep trying until it reaches some threshold. If in the end it doesn't get any correct answers, we ask it to return no additional clue found, because we don't want any incorrect clues.
So to compare our model, we had two previous versions, version 0 and version 1. So version 0 is basically zero-shot prompt. So we just say, here's the clue, make a new clue based off of this for what you think is the correct answer. And then version 1, it's the same as the final version, but we don't have the sort of automated memory step where we go back and we say, this is an incorrect guess, try again. We just create a clue based off of that, the first guess, basically. So comparing our three models, we had decent success for all of them. So our version 0 had 65.7% accuracy, and the other two versions, all of the clues were success, where we define success of it just being sort of a correct clue, which doesn't give away the answer. So we have an example of something that does give away the answer of the answer is OUS, and we say ending of the word dangerous and hilarious. Obviously, that gives it away. And then we've also counted a no clue given and no clue generated as a success as well, because we don't want to have incorrect clues. But for our ClueGPT model, the final one, we have 33% where that no clue is generated. In version 1, it was 40%. So an improvement for the sort of memory step. And then, of course, no incorrect clues given for the version 1 and ClueGPT. So here's some examples of the clues that we generated. So the original clue in line 1 is au naturel, the answer being bear, and then ClueGPT generated the new clue of stripped of covering. So that's sort of a completely new clue. The second one, blank, said ClueGPT guessed sooner, but that was excluded by our sort of like logic exclusion step, so we didn't generate a clue. And then the last one is also a correct clue. So Our version 0, we had a lot of these sort of incorrect clues generated, and it looked like quite often what the model would do is just generate a clue based off of the same words from the input clue. So for this first row, we have Cash in the music business, which is a person, Roseanne Cash. But version 0, it just took those words and it made something new. So revenue in the entertainment industry, completely wrong. And then version 1, it often just made like it didn't have a guess a lot more often. So overall, we learned sort of a few different things from this. Our sort of memory step and the chain of thought prompting really improved the model. When we were trying around with different parameters like temperature and top P, they actually were not as effective as creating a coherent one-word response as you maybe would have expected. The memory step was a lot more useful. It basically would guess the same thing every time until a point where it just would generate gibberish if the temperature was too high. And then, of course, as you would sort of expect, the number of letters that we passed in that was existing in the clue definitely really improved performance. It would, if we included letters, it typically would include the letter in the answer, but not in the right place. So that sort of tells us, I think, something about the tokens, I guess, used by GPT. That's it.